Be telling you guys a bit about Diesel today. So, hello, Pi, Ohio. My name is Christian Wyglendowski. I have been a Python developer for over 10 years now. I've got to have the privilege of working within the awesome Python community and using all the great software in the ecosystem and stuff. I'm a lifelong Midwesterner. This is my first Pi, Ohio. There's always been something in the way in years past, but this year made it happen. So today, my goal with this talk is to give you guys as much information as I can so that you feel dangerous by the end, that you feel like you could take what you've learned and go out and like mix it up and make stuff happen with this information. So that's my favorite thing to get out of a talk, so I hope I'm able to do that for you guys. So here's just a general outline of the talk. I'll be introducing Diesel, letting you know what in the world it is. It is not motor. It is not piston. It is not gears. There's been some confusion just with like all these different motor engine-related frameworks. Diesel is something else. Then we're going to go over writing network applications with Diesel. There will be lots of code and some demos involved in that. I'm going to go over testing and introspection because I think Diesel has some interesting things to offer in that area. And then just a bit about looking into the future. What is in Diesel's future? What's in your future with Diesel? Okay, so an introduction. So it's not motor or any of those other things. It is an event-based application framework, asynchronous application framework. It was created in 2009 by a bright developer named Jamie Turner, and it's currently in its third major release. I work at a company called Bump Technologies, and we use Diesel heavily there for all sorts of services, client-facing services, internal dashboards, all sorts of stuff. And Diesel currently runs on Linux and BSD-like systems, so Mac OS, and supports Python 2.6 and 2.7. It's similar to these other frameworks that you guys have probably heard of, and it's tackling a similar problem. I think it has some advantages, some disadvantages, but we'll go over those. So it's a mature framework. We've been using it in production at Bump for years now, pounded on it with lots of production traffic, and it's not twisted mature. I don't know if you guys were at PyCon. I don't know if it was this last year or the year before. Glyph gave the talk on like 10 years with Twisted. And that's kind of intimidating because that's a long time. They've talked about pounding on some software. But Diesel has been, it's been exercised in production quite a bit, so it's mature. It has a very rich API for expressing network protocols and applications. I hope you guys, that's a subjective thing, but I hope you guys will come to see that as I go over some of the code later on. And it offers what I like to call Pythonic concurrency. I just kind of came up with this while putting this talk together. But the way I look at it, so Python, it takes away some things, takes away some concerns that someone might have when programming. So think like memory management. You don't have to worry about managing memory when programming with Python. In general, that's taken care of for you. With Diesel, it takes care of concurrency for you in a lot of ways, and you don't have to worry about managing concurrency. You also don't have to worry about surprises like the operating system deciding to reschedule, or to context switch in the middle of like incrementing a number, and then all that's and you don't have to lock around those kind of things. You can do some code in like atomic blocks, and I think it offers less surprises in that way, and that's good. Some things you have to look out for. Protocol reuse is hard in Diesel. We don't monkey patch the standard library like gEvent does. We can't just, you can't just throw in the request library or other libraries. I don't know if PsychoPG2, that's probably a C library, so gEvent probably can't use that either. Or maybe they can, I don't know. In any event, it's tricky. We do some reuse. We use the C library that Node.js uses for HTTP parsing. We have that hooked into our HTTP implementation. We use Python DNS for DNS protocol, but that's a little bit easier since it's sort of a datagram-based protocol. So other than protocols, the community is small. In IRC, there's myself and like a handful of others, Chad. A lot of idling in the IRC channel at this point. But I don't know. I see small communities as a benefit too. You have easy access to people who are pretty, in touch with the software. And finally, it's not supported on Windows, and it's not supported on Python 3 at this point. I have started work on a port to Python 3, ran 2 to 3 on the code base, did some other things, but there's still more to do there. So under the hood, you have an event hub, and it's based on the standard library select epoll or libev using pyev. The event hub is what coordinates all the non-blocking actions and timers and other asynchronous events and stuff. And then we also use greenlets like gevent for basically using or implementing coroutines in Python. And we call them loops inside of Diesel. So whenever you hear me talking of loops later, that's what I mean. It's basically, you can just think, coroutine. This is just a list of the supported protocols. This is stuff that's bundled with Diesel right now. So there's anything with an asterisk by it is one that probably hasn't been vetted in production enough at this point to really be like, oh yeah, go ahead and just like plug that in and start using it in your application and you'll be great. But we have a decent number of protocols supported, and a lot of these have grown out of the needs that we've had at Bump. So at Bump, we have more than 15 Diesel applications. I was counting them. I got up to 15 and I stopped. There's a handful that handle like client requests, like heavy protocol stuff, speaking with all of the Bump clients on Android and iOS. And then there's a bunch more that do like very job-oriented work, internal dashboards and stuff. Across all of the applications, we're doing probably about 10,000 requests per second. It varies, but again, that's like spread out on various app servers across different services and stuff. But Diesel stands up to the load pretty well. And then we use these protocols in our applications. So again, those have been vetted in production. So here's some Diesel code, and I'm going to kind of step through this here, start at the bottom, which is the entry point of the program. So diesel.quickstart is going to call the main function. Main function is going to call diesel.fork, and it's going to take the scheduler. It's going to take a scheduler function and an int argument. And so diesel.fork, you can like schedule at runtime, schedule new loops to run. So control over here to the scheduler loop, and it's going to go through this for loop here, and it's also going to schedule a bunch of other work to be done. The diesel.sleep call there is going to cause that particular loop to go to sleep for 0.2 seconds, and control then switches over to the worker that it just forked off. And so this is going to happen a few times. It's going to go back and forth, spinning up these workers, and the workers are going to print out that they've started, and then they're going to sit down here. And if you see on line 29, diesel.wait. So they're going to sit there and just wait until this event happens, this event that they happen to be waiting for, which is just a string. And then control, once they're all sitting there waiting, we have a question in the front row.
So diesel.fork, that's not a process fork.
That's correct. So the question is diesel.fork, that's not a process fork. It's more of a statement, I guess. But it's a correct statement. That is forking a new loop, which is, like a coroutine. Good question. So yes, it is not os.fork. So anyway, control passes, once all those workers are just sitting there waiting, and we've spawned all the workers, then we're back here, and we're going to call diesel.fire, which signals these events signals that these events have happened. And then each worker is going to wake up, do its print, and again, we're kind of bouncing back and forth here. So let me do a quick demo of running this code. And that's not quite the screen that I want. This is. Can you guys see where I'm typing? There we go. Okay, so I'm going to run this. It's going to go a little fast, but you should see, there we go, job started, firing events, jobs finished. So that's basically that happening, and you can see that's where the control is bouncing around from loop to loop. Okay, so that's just like jump into Diesel, getting an idea of how work is scheduled. We're going to go right into writing network applications now. And when I was researching this talk, I came across this interesting RFC 3117 on the design of application protocols, written by this guy named Marshall Rose. And he had what I thought was a pretty good kind of rule of thumb or checklist for when you're writing an application protocol. First, just use a protocol if it maps to your application. So if you're writing an email client, use the email protocols. Don't write your own email protocol. That's pretty, understandable. Second is to define an exchange on top of HTTP, which again, we're pretty familiar with that in the software development world. Rich ecosystem, just makes sense. Use HTTP if you can. And the next one is a little bit less familiar to me, using email. I don't know, it's not as common for applications to use email as their sort of base protocol, but I guess it is an option. And again, there's sort of an ecosystem there already. And the last one is to define a new protocol from scratch that does exactly what you want. So in this talk, we're kind of going to be focusing on this very last option, like the one that you shouldn't do unless all else fails. And the reason we're going to do it that way is for educational reasons. I feel like in terms of understanding Diesel and knowing like this is how you can write an application protocol, this is how the protocols work, it seems like a good way to go through it and to do that. However, we are going to follow some sage advice that, again, I found while researching this talk. And this is a quote by Eric Raymond from The Art of Unix Programming. When you feel the urge to design a complex binary file format or a complex binary application protocol, it is generally wise to lie down until the feeling passes. So I don't know. I don't feel that urge right now, so I'm going to keep talking. So by defining a text-based protocol, we're in good company. All these protocols here, various aspects of your jobs and stuff, are all text-based protocols. FTP is a bit different because only the control band is text, and you have the whole binary for transferring files. But anyway, lots of text-based protocols, rich legacy. HTTP is going in a different direction soon, but for now, we lean on text-based protocols. So for this talk, we're going to be implementing what I call the salutation protocol. So we're all, programmers. Hello World is very familiar to us. And so in some alternate universe, the IETF came up with this idea that they should, ratify this and formalize it and create a protocol for greetings and salutations in Hello Worlds. And so this is the protocol that we're going to implement here. The request is going to be this greet command and who to greet, followed by the standard carriage return line feed ending that all these protocols use, all these internet protocols. This would be the response, the format, 100 greeting, hello, comma, and then whoever it was. We also have an error response for just invalid requests. And we're going to start with building a server and the talk is about simple and scalable network applications. The standard library, Python standard library, gives us a lot of tools for writing simple applications. And so we're going to start and look at a standard library socket server version of the protocol. So starting at the bottom again, the entry point of the program, we're going to create a TCP server, bind it to a port, and give it this greeting handler. And that's where we do our protocol work. For every connection that is accepted by the server, it's going to get an instance of the greeting handler, which is going to run in a loop, and it's going to read requests off this R file. If there's nothing there, if we get back an empty string, that means the connection's closed, and we're going to break out of the loop and end the connection, and that's that. However, if we get some data from the connection, from reading the R file, we're going to parse that, and we have this little parse request, pretty naive function, but it does the job at this point. And it's going to get us the command that was sent and any arguments that were passed to it. If it was greet, we are going to use the W file, which is the way we can send data back to the client, and we are going to send them the greeting. And otherwise, we're going to send them an invalid response. So here is a demo of running that code, maybe. There we go. So Python standard greeting.py, and we're going to do nc-c localhost. It's running on port 2345. If we just press enter, that's an invalid request. If we greet Pi Ohio, we get back a greeting. So there we go. Standard library. It's a very simple solution. Let's open up another netcat here and try this again. Oh, well, we do have a problem. Let's go back and look at what that might be. Where's my presentation? It's at the very end. Okay. So that's a very simple version. It supports persistent connections. We can make multiple requests in the lifetime of a connection. It's 22 lines of code. I mean, that's simple. That's really pretty cool. I was excited when I wrote it. However, it's not scalable. It accepts one connection. Now there are, the standard library actually has some solutions to that. You can put a threading mix-in or a forking mix-in in there. But again, you're gonna run up against some limits when you start forking off processes or threads to many threads if you're talking about dealing with lots and lots and lots of connections and requests. So it does one concurrent client. So let's look at a Diesel version of this same protocol. So first, here's the Python version, just again for comparison, and here's the Diesel version. You see what I did there? It's very similar. So we're going to step through and look at the differences. So here's the entry point of the program. Again, at the bottom, we call it diesel.quickstart. We create a Diesel service passing this greeting handler, which is similar to the way we did it with the TCP server. And we tell it to bind to port 2345. So there's the greeting handler. It's not a class like the standard library TCP server version was, but it is called for every accepted connection, just like with the standard library version. To read the data from the client, we call Diesel until EOL, until end of line. And that is going to get us the data that the client sent. Now, unlike the standard library version, we don't get empty string if there was no data. This connection closed exception is raised, and so that's why we catch that sort of at the outer level. Then we do that same parsing that we did with the standard library version, and we send a greeting with diesel.send, and if it's an invalid request, we send the invalid response. So let's run that, and I'm having some trouble here with there we go. So let's start up the Diesel version. And let's get our netcat clients fired back up. Oh, thank you. That's unfortunate. Is it still? Yeah, I'm afraid to do that though, because what if I have other stuff running? Let's try this once more, please. All right. Thanks. Okay, the socket is still hanging around. Okay, we're going to move on at this point, because we will look at the Diesel version actually running in just a minute. So let's just talk about it. It does persistent connections as well, just like the Python version, multiple requests in the context of a connection. Same number of lines of code. It's simple, just like the plain standard library version, and it's scalable. And this is something I didn't get to demonstrate. It can handle many concurrent connections. It uses, like I said, epoll or what's the KQ on BSD? Thank you. That's what you have at the back end, and it's able to multiplex between all these connections without making thread context switches, without spinning up a new thread and having a new stack for every connection. So you can run many concurrent clients and handle many concurrent requests. So let's talk about writing a client for it now. Netcat is great, but if you want to write client software for this protocol, you're going to need a protocol written in Python. So we're going to subclass diesel.client, and in order to do the network I/O, we're going to decorate those methods with this diesel.call decorator, which basically all it does is so every loop can have multiple connections, and it has this connection stack. And basically, diesel.call makes sure that the loop's current connection, the one at the top of the stack, is the one that belongs to this client, so that you're sending, your bytes across the correct connection. So here's a client. It's pretty simple, pretty short. We have a greet method decorated with that diesel.call. It takes something to greet, and it sends that to the connected server. So one thing that we're going to do here is we're just going to return just the raw string that we get back from the server. We're not going to bother with making a request object or anything like that, because surely after our protocol is implemented and frameworks are built around it, everyone is going to want to implement their own request and response objects for this protocol anyway. So we'll go ahead and just return the raw string. Also, we're going to write a little program that uses the client. And this is how you would use it. So I don't know if any of you were in the talk yesterday. I was a session chair for Jeff Armstrong's Writing a Text Adventure in Python talk, and he brought up a standard library module I'd never heard of before, the command module. So I redid my slides last night to make use of the command module because it's pretty slick for just writing like little command prompt interface or interactive interfaces. So I've got one of those here, and we're going to make use of our Diesel client. We're going to attach to localhost 2345 and call our greet method, print out the results. So let's do the demo now and hope that the port has been freed. That's right. Okay. So let's see. Diesel greeting 0. Hooray. Okay. And here's our client application. It has a smiley face prompt. We can use this, and here's some of that. Wow. Okay. Well, you can do help, and that's like provided by that command module. Anyway, we have the greet command, and we can greet something. We can greet nothing, and that's an invalid request. And we can greet world, and that's a successful request. Let's open another one, and let's greet Pi Ohio again. There we go. So we have concurrent connections happening here. They're not blocked on each other or anything like that. So there we go. A client, a server, good stuff so far. Let's get back to the presentation. All right, so time marches on. The salutation protocol is a success. But people want more. The world wants more. There are flame wars on news groups. Impassioned blog posts are written. And another committee is formed to investigate what is needed in the next version of the salutation protocol. What comes out of it is that it needs to be social. We need massively social because we need to build economies on top of this. It's going to take us great places. So the next version of the salutation protocol is social. You can choose who you want to greet and send them that greeting. And your response is going to be a 101 sent and then whatever you sent them with. And this is the really new groundbreaking part of the protocol. Someone can wait for a greeting for themselves. And when that greeting arrives, or if there's already a greeting, they will get the greeting response, the same 100 greeting response that we saw from before. Well, anyway, so let's talk about how we're going to do the message delivery, over-engineering aside. We're going to use a dictionary for inboxes in this simple version of the server. And we're going to use a queue class that Diesel provides for notification and queuing of these messages. And the queue class has this nice property, and it's similar to the threading queue class from the standard library, where if you wait on something in the queue, if your thread is waiting, if your Diesel loop is waiting, it's going to sit there, and that particular loop is going to block until something comes back to it, and then it'll wake up and continue execution. So here is the updated server. I had to trim off just a bit of the parse request stuff just because I was running out of room on the slide. And I just wanted to be able to show you the important stuff. So you can see we have that inboxes dictionary at the top. It puts a queue in there for anyone, any access to the dictionary if there's not one already. And then you can see the greet protocol handling has changed. It's a bit more fragile, actually. The line 17 there, we're splitting, and what if we can't split? But anyway, this is just for example. So we're going to sort of punt on robust error handling at that point. But in any event, when we receive a greeting, we're going to take the who and we're going to put the message that we found into that queue for that particular who. And then if we get a wait command, we are going to be waiting for trying to get the message out if there does happen to be one. And here's the updated client. We just added a new method, basically, made a little tweak to the greet method from before so that we can pass the two arguments. And then this is the full client application updated. Again, just tweaked the greet and added a wait command. So now we have two commands. And let's switch over and try to do the demo again. There we go. Third time's a charm. So let's start up this new version of the server. And our new version of the client. Control L.
It's the ASCII key, right?
Yeah. All right, Chad. Thank you. I was trying to figure out a way to get an Aspen plug. Oh, Aspen supports Diesel. There we go. Sorry, that's unrelated to this particular protocol that we're doing. Okay, so here's our client. We have a new wait command. We can say wait pi Ohio, and now this client has its connection to the server, and it's just sitting there waiting for a message, waiting for something to happen. Our other client down here, we can send a greeting to pi Ohio. And then when that message comes through on the server, that client is woken up, that loop is activated again, and it receives the greeting. We can queue up a few messages while the client's not there, and then they can come back, and those messages are immediately available. And so we have concurrency. We have sort of this asynchronous message delivery thing going on. The protocol is a smashing success. Okay. So part of what I promised to do in this talk was to go over creating network applications and also to show you some built-in protocols. And I kind of glossed over those at the beginning. But one protocol that we support and that I'll show a couple examples of here is ZeroMQ. Pardon the wrapping on this one. So Diesel has this examples directory in the source tree, and I just ripped this from the examples and just to put up here. But anyway, it's not formatted nicely with the long line number 6 there. But in any event, what this does is this creates a loop, this send message loop, and that loop has this Diesel ZeroMQ socket, which is the way we do ZeroMQ sockets in Diesel, and it does this loop where for x range 500,000, it blasts out a message to that socket. And then at the same time, there's this tick loop running that basically just is other Diesel work happening at the same time. When you run the example, it just shows you that there's other work scheduled in the midst of this ZeroMQ protocol work. And then this is the client. It looks very similar, but basically instead of doing on line 10, instead of doing a send, it's doing an outsock receive, and it's basically able to receive all the messages that were sent by the sender, and then at the very end, once it's done receiving messages, it prints out kind of like just a status message. But let me go ahead and, if I run this, it takes a really long time because that's a lot of messages, but that's kind of lame not to run it. How much time do I have?
Can you drop the 500,000 down?
Yes, I suppose. How's my time?
You have 20 minutes.
Whew, okay, we've got time. This is good. All right. Let's, so Control L is what I want here. Is that what you're telling me?
It's not.
Oh, you know what? I have Control L. That's how I move around. I can't do it. I've got it bound. It's like Vim key bindings for my, I can move around. I like it. All right. Okay. So let's just run that. We'll set up the receiver first. You don't have to. That's one of the nice things about ZeroMQ, I guess. And now we'll run the sender. Okay, so it's sending a bunch of messages. Let's see. Let me get top running over here so we can see the CPU is being exercised. 100% CPU by one process at least. One of them's just sleeping.
Since it's busy, when I ask
Yes.
a question. Diesel, sorry I missed the first minute, is intended to make multi-threaded apps easier? Is that its reason for existence?
Okay, so the question was, is Diesel's reason for existence to make writing threaded apps easier? I would say it's not so much threaded apps, but just concurrent network apps.
Okay.
So it's not actually using operating system threads. It's using, it's using epoll or KQ, something to multiplex many socket connections and be able to, handle many concurrent connections.
So is the fact that whether it's the thread or the whatever you want to call it that's busy loading up the queue appears to be, I guess my expectation would be that the clients should be pulling these messages off as all 50,000 of them are being queued, but it's not getting any.
Well, so it did. Yeah, I'm not sure why only one process was running at 100%. It may be that one of them just was able to blast all the data in, and then the other was wasn't receiving them. But anyway, yeah, I can't explain that particular thing going on there. Another question here.
Yeah, I have a question. In regards to Javent, so I may have talked about it, I missed it slightly. But in regards to Javent, what's nice is that you can monkey patch the Python standard library so that everything that already uses Python sockets or the HTTP libraries or Sleep automatically works synchronously because it basically taps into the Javent hub. Is there something similar with Diesel? Because I suppose that would be nice. I could just use drop in the request library, monkey patch everything, send message, and I could then do HTTP requests, and that wouldn't block my whole.
Yeah, I think I can respond to that. So the comment was Javent uses this monkey patching to basically patch the standard library so that standard blocking calls are kind of magically asynchronous. The short answer is no, Diesel doesn't do that, and it's intentional. The monkey patching is just a bit too, I don't know. That's taking things too far in terms of software weirdness to me. I'd rather not monkey patch everything. It seems like there would just be too many corner cases. I guess it probably works out in practice most of the time, but yeah, we can feel free to chat about that more. But
yeah, it's just in practice. I've never had any problems with it.
Okay.
It's actually Tornado and Javent. Tornado we can use for simple web stuff, and then Javent on top of it.
Yeah.
And it's how they can hack Tornado because it's got its own event loop, and to mix in Javent's event loop.
Yeah,
it works well actually.
Yes, and Gvent definitely is very successful, and lots of people use it. So it's as long as you're fine with all that monkey patching, that's I suppose that's fine. But yeah, Diesel is another option to add to your toolkit at the very least. Okay, so that's ZeroMQ, another protocol that Diesel supports. How are we doing on time here?
Good, fine.
Great. Let's talk about some testing and introspection. So after we've written, or maybe before we've written Diesel code, we want to do some testing. We want to, be able to make sure our code is going to run right. We want to be able to verify that our intention or that our expectations meet what is happening in the real world. We want to be good testing developers. So we write code like this, where we test something that happens in Diesel. Now, one thing I need to highlight here, line 5, this diesel.first call is something that I haven't introduced yet. That basically lets us wait on the first of a series of events. Whichever one happens first, we will get a signal back, and it'll let us know, and then the data that comes along with that. So in this case, we're going to wait for a sleep of 1 second, which is hard to see there, or this event called boom. Immediately prior to that, we are forking off this other loop that is only going to call the diesel.fire boom to make that event happen. And then we're going to, at the very bottom there, assert that event occurred. So let's run this under nose tests.
So Christian.
Let's see here. Yes.
So if the test.
Thanks. So that means if the test fails, it'll be because the sleep completed before the event fired?
Well, just have a look here. So here's nose tests running our test food up high. Whoa, huge monstrous traceback. Not even anything to do with our test. Attribute error, none type object has no attribute fork. The problem is when we run code like this, we need diesel.fork, diesel.fire, all of that counts on a running event loop and a running event hub behind the scenes to coordinate all of these actions. And we don't have that when we just have like a simple test like in this slide here. So thankfully, nose is pretty extensible. And we just wrote like this 5-line wrapper that calls basically the same internal functions, and it's actually an exposed API that Nose has, but before it does that, it starts up an event loop, and so everything that you run, all your code, all your tests happen in the context of a Diesel application with a full event hub and everything. So running that same code with dnose tests runs just fine. So we have test executes, everything is good. So if you're going to be writing Diesel code and you want to have tests that exercise things in the event loop, make sure that you use dnose tests. Another thing, as Python developers, we love the interactive interpreter, right? Like, let's hear it for the interactive interpreter. When I want to poke around with something, when I want to figure out an API, I just fire up the interactive interpreter, import the module, and away I go. So let's do that with Diesel. Sorry, I hope I'm not causing anyone to have seizures with these screen switches here. So Python, import Diesel. Let's make a new loop, diesel.fork, lambda, something. We'll even do none. Lamba. Bah. Whoa, lamb bad. All right, let's do that. There we go. Same type of problem as with nose tests. We don't even have an event hub. We don't have a Diesel application to run this. So thankfully, I'm going to try to switch back to my slides again because I had this great progression. We can't do that. We can't just use Diesel in the interactive interpreter. But like dnose tests, we have dpython. And it's not as bad as you think. So the standard library has the code module, which gives you all of everything you need to create your own little interactive interpreter. And we just basically use the code module. We do a little bit of a trick to let you do non-blocking reads of standard input, and we let you do things like this. So there we go. We forked a loop and it says hi. Let's make that a bit more interesting. Whoops, read line's not working. Diesel.fork. Can I do semicolons and lambdas? I can't.
If you're not worried about the return value, you can just put in an or.
Yeah, I'm working towards something here. Okay, so here's this. We're going to fork off this function, or this loop, as we call them in Diesel. So now we have this loop that we forked off. Things are happening. The event hub is waiting, and then there's our logged message. So you can poke around with anything you want in Diesel. You can open up client, create client instances, send off requests, wait for things to happen, and it all works pretty nicely. So that's dpython. And then one of the last tools, Erlang has some neat tools. Diesel, a lot of what Diesel is inspired by Erlang, sort of being able to write these, many actors, many concurrent things happening, passing messages between, firing signals, sending things on queues. One neat thing that Erlang has is this really cool runtime introspection of your software. You can get a console right into your running Erlang application and run code and inspect the environment and all that kind of thing. So we wanted something similar for Diesel. So we wrote this tool called dconsole. Everything is prefixed with D. Okay, so, I switched too soon. So the way you can rig up your Diesel application with this console signal handler, and you import that and you run it somewhere during your application's lifetime when it launches, and that sets it up so that you can use the dconsole command to get a console into your running application. So let's switch back to here. I've got a version of the server that basically does that same thing, that imports that console signal handler. And Diesel greeting 2. Whoops. Okay, so first of all, you can see that I print out the process ID up there in the log output. If I do dconsole, and what's that, PID 7086? So now I have remote console into that process. Now let's do, we're going to go back to netcat just because it's simple. Okay, so now we've got a connection to our server. Inside the server with this console, we can do dir and look at things. We have this debug tools, and it happens to have this function called print greenlit stacks. And if we run that, and this is hard to see now, this prints out a stack trace or the stack frames for every running greenlit in the system. So every running coroutine that we have, you can see where it is. And this one happens to be the client that we have that's blocked, waiting on until EOL. But you can see very quickly, and it says there's one of those. Like if we had a bunch of clients sitting in that state, you can see at the top left there, it has one in the brackets. That's where we would be. We would see more of those if we had more blocked in that same state. But we can, you can do other things here. You can run code in the actual context of the server. So this should actually cause something to happen. Yeah, there we go. So we ran that in the server. So anyway, it's a neat way to poke around and figure out what's going on in your application if you have to do some like runtime debugging. It's actually come in handy at Bump in a number of cases when we've been like, what's going on? Why are things blocked up? What's happening? So that is runtime introspection and testing and stuff. Let's talk about the future. There's lots more that I haven't been able to cover in this talk. Diesel receive. This is how you do binary formats. You say like a number of bytes that you want to receive instead of like just a line terminator, and it'll receive that many bytes. There's connection pools, thread pools, all these different things for doing different, for building robust, scalable, production-ready applications using Diesel. So unfortunately, I didn't have time to go into all these different things. So where to next? I'd like to see Python 3 support. It's not like a super big pain point for me, but just as like a Python developer looking to the future, it seems to be a good way to go. I'd like to do more API docs. We have some right now that I pushed up, but they're not actually even on our website because I don't have control of that yet. The current maintainer is a little slow in maintaining things. I'm actually hoping to get that role soon, but we'll see. I'd like to see expanded reference docs as well, better multi-process support so that we can have, be able to have real concurrency, real parallel concurrency, that is. First-class support for operating systems signals, so we can say wait on a term signal and then be able to run some safe shutdown code or whatnot. And then finally, if anyone is interested in Diesel, I'd love to have you involved with the project. You can come talk to me or meet on IRC or on the interwebs in some fashion. So that's what I have. This is some contact info. Are there any questions that haven't been asked during the talk so far? In the back. Oh, waiting for the microphone. Here it comes.
Hi. Hello. Okay.
Hi.
I was wondering if you could talk a little bit more about the remote the debugging console, how it kind of works. Does it work remotely over the network, or is it just sort of local to the machine, and how that communication works?
Yeah, that's a good question. So the very first thing is it is local to the machine. I didn't want to open it up otherwise, just for security reasons mainly. So yeah, it binds to localhost. The way it works though, so you have to install that signal handler because the dconsole program is actually the server, which is kind of weird. So dconsole, you fire it up and it starts listening on a socket. And then when it fires the signal to the process ID that you give it, and that process then makes a connection back. And the reason that I do it that way is so that the server itself, like whatever application you're inspecting, it doesn't have to have like a dedicated service port that you like connect to. Because like, let's say you're running 10 of these processes on a machine, that's just too much accounting to have to deal for like how many, all these different service ports, which instance do I want to look at. So instead, dconsole fires up the port, sends the signal to the process connects back, and then you have the console.
Is it speaking some? All right. is it speaking some sort of custom API to do that, or is it just it's opening a socket and you're just seeing the debugging running in the process remotely?
So similar to dpython, like we use the code module from the standard library, we did the same thing for this feature here. So we have a code.interactive console or whatever running inside of the I believe it's dconsole, and then it's just sending off the code to the server, which execs or evals the code and then sends the results back. We quickly patch out standard output, I think, to capture what was on standard output, and then immediately put that back. So I guess what I said about monkey patching earlier, we do it selectively. Selective temporary monkey patching. Any other questions? That was a good one. One more question here up front.
More of a Javent, sorry.
Yeah, here's the microphone.
Okay. Sorry, it's a bit Javent again. What was the design decision? Why not go with Javent? What was, like you said, that monkey patching could be an issue because of potential edge cases. Did you encounter any, or was it just that you preferred rolling your own thing?
No, that's a fantastic question. So when this was created back in 2009, I believe G-Event was also kind of in its infancy. So Diesel and G-Event kind of were, have been peers from the beginning. And it just wound up being that, so the guy who wrote it, he was working at Bump, and we wound up building up a lot of infrastructure on top of Diesel. As Diesel grew, it grew feature-wise. G-Event did as well, and it just, we didn't bother porting our app over to G-Event. And at the same time, there hasn't been a lot of publicity about Diesel. Like, this is the first talk ever on Diesel, so we didn't sort of get the mind share that G-Event has in the community.
One thing I'd find annoying in inverted commas about Diesel is I have to call the Diesel's own sleep functions diesel.sleep, and so it's really just modules have to be designed to explicitly support Diesel, whereas versus Javent, even if the monkey patching is questionable from an ethics point of view, it does the job, and it makes that so basically we can use modules that aren't specifically designed to use Javent. And that's what I like about Javent, at least. So why not do the same?
I guess so. In a way, like I said, I sort of it's not an ethical dilemma for me with monkey patching, but just more of like a code hygiene kind of thing. It just doesn't. I don't know. It just doesn't seem quite right to just patch all of this stuff, all these standard library features, all these language features that we're used to using, and have them just magically work in some new way. I'd rather know when I'm doing something different. So that's just it's a design decision, and I don't know that there's much more to say about it. Any other questions? Okay, looks like we are wrapped up here. Thanks a lot for listening. Really appreciate it.